you for joining me here today. I will be talking about electric vehicles, why they are so important in our lives, with some feedback and with some story behind it, and the realities and the story of Elektron brand and our cars. First of all, let me introduce myself. I am an electrical and electronics engineer. I studied in University of Bath, England, graduated in 2002. I did also MBA, Masters in Business Administration. I'm a race car driver. I can say myself an old petrol head, new Electron head, as I've been modifying cars since year 2000. And then, of course, when the introduction of electric cars came, I became an Electron head, being already an electrical engineer. And I worked in Özel group of companies starting from 2002 with executive roles where we developed and produced lots of electromechanical equipment up to 550 kilovolts and some components, some composite components as well. And we formed up new teams, new companies, established new production lines, and we developed, produced, and sold our products more than 120 countries worldwide. In 2017, I founded Elektron Motors in Germany. I came to Germany to found this car company here as the exotic car brand of Germany, mainly actually. And starting from 2021, I'm also the executive director and partner of e-Autotrack, which is mainly doing training and consultancy services, especially regarding electric vehicles, aftermarket, and maintenance, because all automotive industry is shifting to be a part of electricity distribution management system, and we have to be part of this new electrification transition. So why are EVs vital for the future? As you can see here, if we take a 600 horsepower super sports car, for example, we get an emission of around 260 grams of carbon dioxide per kilometer. If you get a normal 1.4 liter 100 horsepower C segment car, the average emission is around 125 grams of carbon dioxide per kilometer. I mean, super sports cars are way higher, but still a normal car with internal combustion engine is still a big amount of carbon dioxide per kilometer. But as you can see below, whatever the horsepower and the power of the torque of an electric vehicle is, emission is always zero. So for the sustainable business, for the sustainable future, and for the good of our planet, we have to switch to electric vehicles for sure. So as you can see here, on the left-hand side, there is a very beautiful engine of a Corvette ZR1 with around 2,000 moving parts. Pistons, piston rings, cranks, springs, spring valves, and this has a supercharger as well. So lots of parts to be developed, produced, and assembled together. And in the same company, General Motors, their permanent magnet electric motor, they only have around 20 moving parts in an electric motor. So, and electric motors have been in our lives for a very, very long time. Starts from trams, trolleybuses, refrigerators, washing machines. They're in our lives for a very long time. And we all know that the efficiency is much higher than internal combustion engines from our high schools, middle schools, etc. So we can easily say that actually ice age is over. And this is not only about zero emission vehicles. You know, when comparing internal combustion engine cars with electric motored cars, people also always talk about zero emission, but it is much bigger than that. You know, this is like a map of the production, supply chain, and production chain. And you can see that, you know, when you have around 2,000 parts that we just mentioned, they have to be produced individually by different tier 1 suppliers. Then they have to be sent to the distribution centers. Then they have to be gathered together and sent to assembly plants where they assemble all the parts together. So the cumulative carbon footprint of this is too much, because it includes component production of all those individual components, and they have to be sent. The logistics is there. So this shows that internal combustion engines are just not feasible, even though now there is a new trend about alternative fuels. You know, just changing the fuel doesn't change much, because the graph and the picture is much bigger than that. So smart grid is also a very important point why EVs are vital. Smart grid is basically a smart energy management system. You know, we have been using this in energy sector for a very, very long time. As you can see, up left-hand side, there is a substation with the transmission lines. You know, in substations, there are capacitive voltage transformers that are used for communication over the transmission lines in the grid systems. So in electricity distribution system, this is already used for years. And in recent years, as you all know, there are smart homes which are getting more and more popular, where you can turn off or on your lights, change your air conditions, situations, or window blankets, etc., remotely. So the smart management is also there in low voltage side. So smart grid, actually, electricity energy sector has been working on this for decades now, and it will be used widely in the future. And electric vehicles are a very important part of this system. Why? Because the problem with electricity is that you basically cannot store it. This has been a problem since the beginning of the introduction of electricity. So we have a duck curve here. You can see why it's called the duck curve, because of the shape. So this duck curve actually shows the net load of the system during during a day. So this is a duck curve of California. You see that during the daytime, when there is sunshine, the net load is decreased. The stomach of the duck is getting lower and lower as the time passes, because even though the general net load, general demand is increasing, the renewable energies make the net load on the grid lower and lower. And when you look, you see that starting from around 5 p.m. to 10 p.m., the peak load is between these areas. That's where we called the peak hours. So because you cannot store electricity, when you want to do investment for the production and distribution of electricity, you have to consider this curve, and you have to put a tolerance on top of that peak net load curve, and 10, 15, 20%, and you have to make your investments accordingly in order not to have problems with the grid. So what will electric vehicles will do about this? You know, when you consider the smart grid map I just showed you, and this one, consider that you all have electric vehicles driving from offices to their homes, from your office to your home, and because peak hour is based on people coming from the work and turning on, you know, the oven, the lights, the kettle, and the television. Everybody is doing this at the same time. That's why the peak load is there. So when everybody comes with the electric vehicle to their houses, and they plug the car back into the grid, like the one on the right-hand side you can see here. Of course, you need two-way smart meters, where the car will be able to give the electricity back to the house. Then you can flatten this curve. You can give this electricity at the peak hours, where actually is the highest price for electricity as well. And you flatten this curve, the net load curve, and you arrange your car in such a way that it will get back the electricity when there is low demand, everybody is sleeping, etc., during nighttime. You can even arrange it such a way that, you know, the kilowatt hour of electricity is below, I don't know how many cents, let's say. You can determine how many cents it is. And below that point, the car will get its electricity back. This is very convenient, actually, because let's say you go for a business trip, you plug your car into your house, and it can get electricity during night times for cheap and sell the electricity back during daytimes when you are away. I mean, this is giving a great freedom for, a free economy as well. So what about hybrid vehicles? Now I mentioned there are 2,000 parts in internal combustion engine and 20 parts on electric motors, and there are around 20 to 30,000 parts in an internal combustion engine cars, whereas there are around 2,000 to 3,000 parts in electric vehicles. So hybrid cars actually they have both. 20,000 plus 2,000 minus 1,000, let's say, because there are some parts that doesn't have to be used. So you can see that you combine both cars in one car, which is basically not feasible and sustainable. So hybrid vehicles are just transition elements to electric vehicles because the car has an electric motor inside and an internal combustion engine inside. This gives the sensation of using an electric vehicle to people who are not used to it or have some question marks in their heads, and it can help people to get used to electrified automotive sector. And when we come to the birth of electric vehicles, as I told you, we are also giving trainings, and one of the things we asked during the trainings is that what people think about the first electric cars came to life. And people say generally 1980s, 90s, 2000s, etc. They are around for 10, 20 years. But when you look at this photograph and this slide, it is much, much before that. 1828 was the first known date of an electric propelled vehicle. And a lot of people worked on it, but it wasn't until 1884 when Thomas Parker produced the first practical production electric car. And when we came the beginning of 20th century, electric vehicles were very, very dominant. You can see on the right-hand side the electric car charging stations in Chicago from 1916, and in the middle you can see the electric trucks being charged. Because electric vehicles had big advantages over internal combustion engine cars those times, because in order to start an internal combustion engine, you need to start the crank, as you all know. So in order to start crank, you had to have a lever and turn it, rotate it in order to start the engine, which was a very hard job at those times. You all remember from old movies, for example, and airplanes had the same thing as well. You just turn the propeller. So it was very convenient to have electric cars instead of internal combustion engine cars. And when internal combustion engine cars passed electric cars, it is ironic actually. The starter motor was introduced, the electric motor for a starter, and this basically killed electric cars. And birth of electric hypercars. The first car reaching 100 kilometers per hour was not an internal combustion engine car. It was an all-electric vehicle, and it was before 1900s. It was made by the Belgian driver Camille Janazzi, and the name of the car was La Jamais Content, the never contented. So actually, the first hypercar, we can say it was all electric as well. So we talked about the advantages of EVs over internal combustion engines when you think about sustainability, renewable energies, and the global warming, the good for the planet. But electric vehicles have also big technical advantages over internal combustion engines. Like when you look at the graph, you see that, for example, the torque curve of EVs are much smoother and better than internal combustion engines. In motorsports, there is a saying, horsepower makes you sell cars, but torque makes you win races. So electric vehicles, electric motors, giving the torque from zero is a very, very big advantage over internal combustion engines, because in an internal combustion engine, you have to rev your engine in order to reach the torque and power levels. And in electric vehicles, there are only generally one or maybe two or mostly three, at most three gears. but generally 1 or 2. And internal combustion engines, you have 6, 7, 8, 9. So you lose time with shifting gears all the time. And when you shift gear, you get back to the point where the torque and power value is not at most. And here in the curve, you see that the power level of electric vehicle is increasing in a very good synchronization with the torque curve. As the torque decreases, the power increases. So it is a very, very convenient and very smooth acceleration figure. Very smooth acceleration figures can be reached with electric motors. Another technical advantage of electric vehicles is the handling and road holding characteristics. You know, in a car, the center of gravity is very important because when you turn, as you can see from the middle graph, you have the lift, you have gravity, you have the lateral acceleration and yaw. So the handling characteristics of the EVs are much better than internal combustion engines. Here you can see the Porsche Panamera, for example, and the Porsche Mission E, which is basically the Taycan. You see how high the motor of a Panamera is, you know, and how unevenly distributed the weight is. You know, in order to have the best characteristics, you need to have as low as possible center of gravity, and the weight should be distributed evenly, as low as possible and as middle as possible, both from the front and rear axles to the middle and from left to right as well. Therefore, electric vehicles have this very big advantage. You see in Taycan, you have small, very small motors just over the axles and very low as well. And the battery is on the ground as well. So the handling characteristics is much better than a Porsche Panamera. And EVs are always like that, depending on which target segments, they target. So why Elektron? Yes, I've been, you know, when I was a child, I used to run very fast. Actually, I still run very fast. And I was winning all the races. People used to call me Cheetah. My friends used to call me Cheetah. And when I was playing football, they used to call me Armando Maradona because my name is Armağan. And I was a little bit like a chubby boy. So, and I was running like a cheetah. And cheetah is not only about straight line performance, as people generally see, it is about agility as well. So agility and the road holding and handling characteristics of the animal. This is actually very similar to Electron as well. And the second, these are my favorite animals, by the way. I like flying a lot. And I love eagles. It's about freedom, it's about strength, etc. And when I was a child, when running and winning all the races, Ayrton Senna came, you know, at those times, and he said being second is to be the first of the ones who lose, which is generally my idea as well. Whatever I do, I try to be the best. I try to do the best. And when we have a car, I will try to be the fastest, be the most powerful. That's why while I was doing modification, for example, the Corvette you saw is a 1,000 horsepower Corvette with all forged internals and a wet nitrous system, progressive nitrous system. And I have a Chevrolet Camaro Turbo still, 1,500 horsepower with a 94 millimeter turbocharger. So whatever I did, I tried to do it for the best. So Elektron was like that as well, of course, from the beginning. So you can see some very bad graphs here, drawings. These are the first step. Of course, we developed, as I mentioned, many products. We produced them, and we did, you know, I modified many cars, but developing and producing a car is a very different thing, as you all know, and it's very hard as well. So first, I outsourced the design of the car to a graphic designer, and we got the top left-hand side car. Then we made changes according to my taste to get the car in the middle. And of course, we were also looking at some names, some ideas about what the name would be. So we came up with Ankira, Aquila, etc. And then these funny drawings are my studies about the headlamps, as you can see. different kinds. So when we had this 2D graph, 2D sketch, we outsourced the 3D to another engineer to have the car on 3D. And we worked on the car for a long time. And as you can see, these are the different progress, let's say, different steps. And this showed us actually, because I was not experienced at that time, you have to freeze your 2D design before getting into 3D. Because if you try to work on a 3D design, you waste too much time and energy. So, of course, at those times, I didn't know about those things much. So this was just an experience at that time. But eventually, the car got better and better, and we called it Electron 1. And we were supposed to launch it in Geneva Motor Show in 2020. But as you all know, this never happened because of the pandemic. So everything stopped. So we also had a, we were talking with an Italian Turkish team of Formula E that they got in touch with me in order to get technical know-how of a supercar and a hypercar, how they work, what's the difference between them. And they wanted to use the powertrain of Electron 1 into their Formula E car. That's why we were working together. But after that, of course, that didn't happen. And now they are working on their own hypercar car. But anyway, when the Geneva Motor Show was cancelled, I had to stop everything. But I had to make everything better because I had the opportunity, because everything was stopped. Even motorsports were stopped, OEMs stopped. So I found some very capable engineers under the lockdown. So we said, because I was mainly the designer of Electron 1, and when I found these people, I said, let's design a car from scratch to be the best. Because Electron was a super sports car with 1,300 horsepower at that time. So it was supposed to be the best in its own segment. But now we had an opportunity to build the most powerful production car ever, 2,300 horsepower Electron Quasar. So we worked on this car together with these engineers. And, we got the reference of a water drop, which is the most aerodynamical shape, as you know. So we got that and we designed the car around it. And we decided to have a new brand, a new start after Electron 1, and Elektron Motors, the next generation exotic car brand, where we have Elektron Quasar hypercar with 2,300 horsepower, as I mentioned, 4 electric motors, 2-speed gearbox. Top speed is 450 kilometers per hour. It is limited because, with this horsepower, you can go well over 500. And I decided to have 2-speed gearbox as well because not ruining the acceleration with a very long curve of 0 to 450 or 500, whatever it is. So we have 2 speeds. And, when you want to have an exotic car brand, you cannot just have one hypercar. It is not sustainable business. It is not your brand identity. Brand identity you cannot have like that, because you can only produce 100, 200, 300 hypercars, for example, in total. But what will you do afterwards? If you cannot produce a couple of hypercars, it's a big risk as well regarding business. So either you have to give some engineering services, some design services, some component development for other manufacturers, or you can be a real exotic car brand and have a second car, third car, whatever it is, you become a car brand. So, of course, this is the way we wanted to have. So we also developed, and this is the successor of Electron 1, by the way. The Electron 2 was super sports car. 1,400 horsepower, 3 electric motors, again 2-speed gearbox, 360 kilometers per hour top speed, which is also limited, and 0 to 100 is around 2.1 seconds. And these cars compare a lot of components so that actually Electron Truva will be writing the rules of a super sports car segment from the beginning when it's out. So, as I mentioned, building the brand identity is very, very important because the owners of super sports cars and hypercars, you want them to feel the same feelings you have, the same passion, determination, and love towards the brand when they sit in front of that steering wheel. They should get connected to it. Therefore, the logo is also very important. When we designed this logo, this was the main point in my head. And you can see there are two E's. One is looking left and one is looking right. So I designed it in such a way that, the left-hand side was, of course, you can say it's past, and the right is the future. The left is gasoline, the right is electric. The left is old school, the right is innovative. It is not old school is worse than being innovative, but it is old school. In our brand identity, we think about future. We think about innovation. So we have to leave old school. So when you look at the writing, the font also, I designed the font in a way that, you can see in the E's, the E's are like powerful futuristic machines, and the color blue is about trustworthiness, and it is my favorite color, by the way, as well. That's one of the reasons why I put blue. And when you look at R, you see that it is moving towards right, and it is futuristic. And it also gives a small message to Tron Legacy, because I like that movie series a lot. And when you look at the O here, there is like a little dot on it, but it is not a dot. It is a hexagon, which, as all of you know, it is the most optimum design with high strength and less material as possible. And that O is kind of conserving it, making it safe. So it shows the strength of the brand. And when you look at the logo itself altogether, it looks like a wing as well. So it is like the freedom. It shows the speed, and because of the shape, it shows the elegance, because elegance is also very important in our brand. And you see like two arms open to the sides when you look in the middle. So it shows the sincerity of the brand as well. So we are the next generation exotic car brand made in Germany. So another very important point with our brand is that our brand has two legs. There are some companies that sell road cars to be active in racing. And there are some other companies that are in racing to be able to produce and sell road cars. We are 50-50. I mean, we have two legs. They're at the same importance. We would like to produce road cars, and as a racing car driver, we will produce the race cars as well. And all of them will give the same kind of sensation and satisfaction and experience to the end user when they drive an Electron. And without one leg, the brand identity is gonna be missing. So in the future, we will have Electron racing as well to race in the electric racing series and Formula E, for example, as well, EDTM or some other racing series for sure. Here, a small teaser of Electron. So these are different sketches and renders of Elektron Quasar. Of course, the company is situated in Frankfurt, Elektron Motors. We are the real Hessen brand with a all-electric German brand. So this is our hometown, Sempropar, in Frankfurt. And this is the Elektron Truva. Both of these cars will be on the roads to be the best of the segments that they target. And thank you for listening. If you have any questions, you can always write to me. You can click our website and get in touch. Thank you very much.